Okay, this is Eric Linwood back with you with more self-elevated EDF/spring power universal exoskeleton armor updates. And I woke up this morning and I was like, hey, why not just build a robot arm? So I went and I just hobbled through the stuff I already had through here, and I basically built this arm here. And it's got full range of motion in the shoulders. If you want to tilt the arm out, you can tilt the arm out. If you want to raise the arm up, you can raise the arm up. If you want to spread wing, you can spread wing. But it's got full range of motion. Up, forward, down, tilt, out. So it's got full range of motion. As you see, it's elevated. All I had to do is mount that piece that I got to there. I want to get two. If I were to do, I would get two and then weld them together with a straight bar. That way I have one of these basically a ball jointed cylinders with double tube with the axes in there. I have two of them, one on each side. I just basically cut it off a bike, but this is basically what it's doing. It's the steering mechanism off a bike. I cut the forks off, took the handlebars off, cut it off the bike. But all the thing I would have to do is get two of them and weld a straight bar in between, and I have one for each arm. And then I can go back with a caster wheel and do it the same way. But it was fairly simple. And I'm just doing it because a lot of people, they probably think that I can't do robotics and that that's why I do what I do. I just know, like, for one, this actuator motor, I could make that with my design. I could make that actuator motor built into the armor structure itself. With my actuator design, with my dual clutch technology, I will be able to, this motor, instead of sticking out like this big eyesore, having this big piece there, this piece and this piece will be one. With the motor in the center, with my miniature, basically magnetic clutches up and down, controlling the shoulder and the elbow. And this unit only controls the elbow. See, I'll be able to take this same mess with less material with the design I'm doing and build it directly into the forearm and get shoulder and elbow power capabilities. That's one thing. And then for two, the actuator motor is way too big. Just the length of it mechanically. If you wanted to do something with your arm, like this for a leg, yeah. But if I just did it anyway, just to show I could do it, because I mean, you can easily put a smaller actuator motor on there. But in general, it should be half the size. It literally should be half the size. That's why I built a hydraulics, because with a hydraulic unit, it'll be able to do it half the size if you wanted to do an actuator setup like this. But like I said, I would rather do the electrical setup. It would be a lot faster response, and I can compact it in the forearm or the bicep area itself. Motor, gears, magnetic clutches, and all, and still have power at elbow and shoulders. But other than that, it's working out and everything. Let me plug it up for you. Give me 1 second. There we go. Okay, I got it plugged. And it's like I said, it's not a very hard concept. And then another thing is, like I said, the slow. See, it kicks off, and then I gotta turn the motor back the other way. But like I said, it's something that I can do. It's just slow. You see how slow that's moving? You see how fast I just move that camera close to there? That's where I'm getting at. I mean, you're great. I mean, you're gonna get power, but this is what you're gonna lose mobility. You're gonna be bulky. You're gonna lose flexibility with a setup like this. I'm just being honest. With a setup like this, like if you look at the Raytheon, the most advanced exoskeleton, the reason why, if you pay attention, that it has the flexibility and the range of motion, it doesn't use any actuator motors like this at all. It doesn't use no hydraulic setup like that at all. And it sure don't use no pneumatic setup like that at all. Pneumatic wastes a lot of power, takes a big old compressor, makes a lot of noise. And I mean, if you know it, I do mechanic work and I do air tools. You gotta have a huge tank to run those air tools. Huge. I mean huge. to have the amount of pressure that you need to keep doing your job. It's going to be the same thing with the exoskeleton. I'm just running like something that'll fit in your hand, like an impact wrench. Now imagine 10 impact wrenches running at the same time. How big the air tank would have to be to keep it mobile. It's just simple mathematics is where I'm trying to get at. A lot of people not understanding the mathematics of it. They're just looking at something and be like, wow, it's neat to me. And I like robotics. Don't get me wrong. It's just in the manner that I see it being incorporated into an exoskeleton, it's just wasting money. And also it's in some instances a waste of time. And then it's just not feasible, dude. I mean, it's feasible in a certain extent. Like I said, and the problem is that we don't have good enough actuator motors. Is what it is, and that's why I was redesigning that. That's why I redesigned that actuator motor that I showed the blueprint up with the dual magnetic clutching technology. That way, you don't have the delay for its back and forth time when you push your arm back and forth, back and forth, back and forth, back and forth. I mean, if you do that with if I was trying to move like this actuator, I would burn it up. And it still wouldn't even move that fast. I'll be literally fighting against it, trying to move that fast. That's what I'm trying to get at. And for is the technology incorporated at the moment. That's why, like I said, if I was to go robotic, I wouldn't go buy nothing off the shelf. I would literally want a CNC machine and machine my own parts. Because like I said, I can get, with that size motor, instead of just having power in the elbow, I can have power in the elbow and the shoulder, with the motor itself built into the forearm instead of that big piece in the way. That alone, using a hydraulic style, actuator style like this, or a pneumatic, is going to limit your range of motion and make you bulky and limit you from doing other stuff. Now something like this, maybe I have a mount a gun to or something to be okay. But like I said, I still rather use my system, because also, like I said, the way I did the gears in the elbows and the shoulder, or if you want to do hip and knees, because the way I did that actuator system, I control your ankle, your knee, or your hip, and then scale it and still do the same thing with your arm. So that actuator system will work with both arm and legs, the one I designed. And it's a lot more compact than this. And with the magnetic clutches, it's going to grab a lot faster, have better reaction time, and you're not going to burn the motor up. But yeah, this is Eric Linwood, and I'll be back with you with more self-elevated EDF/spring power universal exoskeleton armor updates. And I might just build a robot just cause. But I just know the difference between the two. Or for us, what will work and what. It just technology ain't got, like I said, I got a feel ready prototype. Everybody else talk about 5-10 years, and then the stuff that they're using, like I said, is limited in all those fashions that I told you. But yeah, I'll be back with you with more updates.